good morning all. It's nice to see a smaller group, and maybe we will be able to have some interaction on the way through. Stats can be a bit boring, so we want to keep everyone awake and interested this morning. Perhaps a better title for my talk might be, how many seed silos do I need? And have we given you the information with varieties to actually change your decision on what you might put into your seeder once you know where you're coming from in the season, or what the predictions of how the season might pan out for the coming 12 months. So do you have the information to say, if I have good stored soil moisture and there's a break for an early plant or a later plant, do I know which variety I should be putting in those circumstances? If you've got a dry start to the season and there's a predicted wet or dry year coming up, have we given you the information out of the national variety trials to actually use or have the flexibility to make a decision? And to me, it's a bit like hedging your bets with an investment portfolio, okay? Why do you need diversification? It's about managing risk against return. So if we just think to ourselves and draw the analogy a bit further, why do financial advisors recommend that we need this diversity? Why would we want not just one variety or one particular stock or particular type of share that we might want to invest in? To make those decisions, though, you actually need to know what the potential or the performance potential of your stocks might be. So there will be many environmental challenges that are going to affect you over the coming season. Some of these you know, some of these you may be able to predict, and I stress I'm not talking about predicting the future. We're talking about giving you the best summary of past performance of varieties to take so that you can make a better decision of what the future might bring. But you need to understand what those varieties are doing. I'm not convinced that at this stage we can give you that good information, which is why we're moving to a better analysis system. So the key messages for the talks today. Rule number one, don't use individual trial results, okay? And I might keep harking back to that. Haven't got time to go through the reasons for that today, but it's really, really important. The best information you can get from the national variety trials is by combining data across years, across trials, across locations. So then you'll enhance the chance of selecting the most appropriate varieties. The current long-term analysis is based on geographic regions, so we report information on Agzones. I want to dispel a bit of a myth, or at least question it, that this is giving you the best prediction of the variety performance. Okay, so the big tick, we hope, is what we're bringing to you and running education packages, hopefully over the next 12 months, to help you understand the additional information that we can give you from the new long-term analysis of NVT. So the data I'm talking about today is the data from 2008 to 2012 NVT data, and it's a long-term analysis based on all of this data right across the country. All of the NVT trials have chosen to focus on main season wheat. This is happening for other crops as well, but we'll just look at one specific crop. And in this collective database and the analysis, there's 383 varieties, 577 trials. So it's a huge amount of information. GRDC invests big dollars in collecting all of this information. So we need to be very, I guess, very careful and clever in what we might do in interpreting that information. This is how it might look for data from one of the Agzones in WA. So I've chosen to focus on Agzone 2 today. There's a total of 64 trials in Agzone 2, but I stress the analysis is on those 577 trials, but I'll be reporting results based on the 64 trials in Agzone 2. And there might be some of your favourite names. There's 5 years, and I've just pulled out a site in each year with the varieties that were grown there. So the first thing you can see is there's lots of gaps. Not all varieties are grown at all trials across all years. That makes it a really complex for us as biometricians to analyse, and I won't go to the nitty-gritties and bore you with the analysis today, but I'm more than happy to discuss that with anyone who's particularly interested in that. So you can imagine and it's an averaging process, you can imagine when you're trying to average across performance at all of these sites, given all of those gaps, particularly with the different yield, trial yields, so you can see Coolin, is it in 2010, is a really low yielding site. You've got some moderately yielding sites and some high yielding sites. There's a whole wealth of information and statistical models that go behind a sensible averaging process there. So you have to trust us on that one. So what are we currently giving you? And this, I guess, we shouldn't have to apologise for us. It's best practice in the world. So the UK variety trials, I'm not sure what they do in the US, but they will come up with some overall mean. We give you a regional mean, which is based on a geographic area. So you can see here there's a regional mean for Agzone 2 based on the 64 sites there. And you can see the yield. I've kept it in kgs per hectare, but I've used this little colour coding thing here just to try and help you get a feel for how high you are above the site mean. So a lot of the brochures have percentage of a variety. This is percentage of site mean. Dark is good, higher yielding. If you're around site mean, you're going to be white or 100%. So we're going up in 5% increments. So we can look at, on average, which is the highest ranked yielding varieties, down to those which are still about 5% better than the mean. Across 64 sites, though, is this the best we can do? From Coolin to Bunteen, across that huge area, we come up with one average figure. What the new analysis method does is actually fold this information out to try and give you a bigger or better picture of how the varietal performance might change within that Agzone. So it gets busy, and there's no pain for no gain, but you will be confronted with these tables that start talking about environment groups. So they're groups, and I'll define them in a minute, but environment groups, and we can see 5 of them here, are groups of like trials within that Agzone. So there were 64 trials in Agzone 2, and we've just split up this regional mean for 64 to show you how that ranking of varieties might change in different environment groups within that Agzone. So we can see environment group 1206, Mason Korak are still the top yielding. Emu Rocks popped up 1 in rank from what it would have given you in the overall regional mean, and it's, things are reasonably consistent. Mace, in terms of varieties, Mace and Korak tend to do pretty well all the way across, and Yitpi is around about 5% better than the site mean in most of the environment groups. But the particular thing of interest, and this is where the power of the new type of analysis comes into it, is if you look at, for example, something like Cobra, okay? So you're getting an average of 2.71 here, which makes it look pretty similar to Westonia and Wild Catcham. Westonia and Wild Catcham tend to be pretty consistent across most of the groups, but check out what Cobra does between the two environment groups. It goes from actually the lowest yielding in this environment group. So some sites within Agzone 2, Cobra will have quite a reduced yield relative to other varieties, whereas at other groups of trials in this environment grouping within Agzone 2, it's actually the top yielding variety. And the effect of collapsing down to regional means and averaging across all of this differential performance we see in the environment groups is that it masks the variety differences, okay? Averages will just squeeze everything down and make them look pretty much the same. So you're losing the fact that Cobra on average will do this, and if you're a grower who's growing in this environment group, well, you probably wouldn't consider cobra. Or if it was a year coming up that was likely to fit within that environment group, then you'd probably be very wary of growing cobra. Whereas if it was an opportunity here, perhaps you'd say, well, I'm prepared to take that risk to try and maximise yield over some other varieties. I've picked on cobra, I don't mean to be selective, but you can see there's a few others like wild catcham that will actually perform better in some environment groups than the average would suggest that it may. So I've tried to give you these results up front. This is how the new, I guess, package of information that we give you from NVT, how we'd like it to look. And we're looking for feedback from people as to how useful you think that might be, or how we need to refine that to make it more relevant to how you'd like to use it. So what are the environment groups? They're a collection of trials that rank varietal performance in a similar way. Remember I said that if you've got differential performance like cobra and you average over something that's performing differently, you're just going to mask that difference and bring it back closer together. So what these environment groups say, I'm only going to pick out the trials where the varieties are ranked in a similar way, average over that, reinforce your information, give you better information, but I'm not going to average over a group of trials where the varieties are ranked in a different way and mask or throw away that information or hide it from you. So you're probably a bit more interested in what these environment groups might actually contain or what they might mean. So I've split them up. These are the 5 environment groups that I gave you some variety means for, and just shown you firstly, the number of trials from each year. So remember the analysis was 2008 to 2012. There were a total of 64 sites. So environment group 12.06 has all the sites from 2010, or pretty much all of the 2010 sites. So we're saying within 2010, the varietal performance at all of the trials in NVT were pretty consistent in Agzone 2, so we're grouping them into one like environment group. But we can see that this environment group is quite different to how the varietal performance was in the 2012 trials. Okay, there's 9 trials from 2012 that actually rank the varieties in a slightly different way to what would have happened in 2010. And I mean, you know, I'm a biometrician and I'm from Queensland as well, so you have to forgive me both of those traits. But if these seasons mean something to you here, with what you've seen happening out in the field, the difference between 2010, 2011, 2012, you start to get a feel for what environmental challenges or stress patterns may have been to cause that differential varietal performance. Some years are more stable too, so we see 2010's pretty much in one environment group, and 2011, there's more to come, so I won't say that just yet, and 2012 has the majority of its sites in one environment group. Okay, I've simplified it down a bit, so I'll just expand. Here's our old 5 environment groups, and I put 5 up before just to show you the highest frequency of how many trials you'd get in each of these environment groups, but there are more. There's some with less sites. So if we continue the year story, 2010's fairly consistent, all the trials are in one group. 2012, there's the majority in one type, but a few sites have sprinkled out. And same with 2011, there's a bit more interaction with how the varieties are ranking across those sites. Numbers don't mean much, so let's actually look at some of the trials that you may know or have a feeling for about why they might be in different environment groups. So there's 9 trials at those sites that are in one environment group in 2012. I love your names, I can't even pronounce some of them properly, so I won't try. There's one site that split off into a different environment group and looked more like a 2011 and 2009 trials. And there's 3 sites from 2012 that have ranked things in a slightly different way. So rather than averaging over all of that and mixing up differential performance, we've actually separated the performance out over those trials in those years. That's 2012. If we look at 2011, there actually is a bit more diversity. You've got 6 sites in this group, 4 in that group and 4 in that. So there's more interaction happening between those trials. And again, I don't know if these look to be sensible groupings or if you've seen the NVT sites and you can get a feel for, based on the environment at those locations in this year, whether you'd expect to see some differential performance across those sites. So, the current long-term analysis, and that, remember, that's going back to your regional mean. It averages or reports by geographic region, so you get one mean for Agzone 2. And what we're finding is it's averaging over trials that are dissimilar. So there's a lot more diversity, a lot more information there we can give you. Decision making can be improved, but how do we measure which of these trials are similar? How do we decide what goes into each environment group? So we've got 5 minutes. I need to digress and give you a quick stats lesson before I can show you, I guess, some justification for how we work out these environments group. So similarity, we're letting the data dictate to us. We're not trying to measure environmental covariates and guess what stress patterns or rainfall, temperature, storm moisture is forming these groups. We're letting the varieties tell us which sites are similar, which trials are similar, and which are dissimilar. So similarity is measured in the agreement of ranking between each pair of trials, okay? You're going to see some pictures like this, and if you look at my paper, some of the biggest questions were how the hell do we interpret these graphs? So here's the yield of variety A at site 2, 5.5. Here's the yield of variety A at site 1, 3 tonnes per hectare, sorry. So if there's good agreement between the ranking of varieties, you're going to get something that looks like a straight line with a correlation of 1 between the yield performance at each of those 2 sites. And the sciencey term for that is there's no variety by trial interaction, okay? Somewhere intermediate is when you start to deviate from that line. So you can still see there's a bit of a bottom left to top right type thing happening. This shows there's some reasonable agreement in ranking, correlation of 0.6, and there's still a little bit of, there begins to be a little bit of interaction. Okay, the final one is where it looks like a random scatter shot of points. So there's no agreement in ranking of varieties. This variety is the top ranking at site 2, and it's actually the 3rd lowest ranking variety at site 1. If we averaged over that, we'd lose a lot of this differential information and just collapse everything back to a mean. So we don't want to be doing that. So you need to just get your eye in for something that looks like a straight line, okay, as opposed to something that looks like a shotgun scatter plot. And between those extremes, there's perfect to 0 correlation. So, down to the real data. I've picked out 4 trials in, nearly at the end, 4 trials in Agzone 2, okay, in 2011. And let's look at the plots of how similar the variety rankings are. So Bunteen and Goomerling have a correlation of 0.6. There's reasonable agreement in variety rankings. But if we take 2 sites, Goomerling and Coolin, they have a very low correlation or very poor agreement. It's like a shotgun scatter. And if we think back to those environment groups early, we don't want to average over the performance at those 2 sites. We actually find they've occurred in different environment groups and we want to report that information or performance separately. So just because you're within the same year, within the same Agzone, doesn't mean that the NVT data is going to give you the same varietal performance. That doesn't mean you should go to individual trial information. We're trying to make the long-term yield analysis better. Let's pick out 5 years of information. So I've picked Wongan Hills just to see is there reasonable agreement at the same location in what you see the varieties doing across years. Well, sometimes there is sometimes there is high correlations. Okay, so that 0.65 goes with 2010 and 2012. There's reasonable agreement there. But for some years where you've got really different seasonal influences, the results at Wongan Hills are going to give you really different varietal ranks or information on which variety you should grow. And that's why you never use your individual site, because if you looked at 2010 results and said, I'll pick that one, you'd pick the best one from 2010, which the top 3 from 2010 could well be one of the lowest ones in 2011, okay? It's really, really quite important stuff. So, decision making can be improved by averaging over similar trials. What we're finding is, though, similarity does not align with the current geographic regions or Agzones on which we're reporting the information. So we really believe we need to change that for you, give you more information, which will be harder to sift through, and we don't apologise for that. But collapsing it back to a mean is really hiding from you a lot of the differential performance that the varieties are giving you, and perhaps hiding some of the surprises that you may experience when you actually grow them in practice. So, I don't know, I'm a humble biometrician. Oh, there, I can see Alan up the back. So any hard NVT and agronomy questions, Alan Bedgegood's in the audience to help me out on those, but if there's any time, we're happy to field a few questions.
Questions? Steve? Peter, right up front, Peter.
Bob French from the Department of Agriculture and Food in Western Australia. I'm interested in how you're going to present the results of this new analysis. Are you going to present results in terms of the way you've done it up there, so environment group 1, 2, 3, 4, however many environment groups there are, and what sort of descriptions of the environment groups are you going to give growers so they can use that information sensibly?
Excellent questions, and I guess that's what we're grappling with at the moment, and we need feedback. Alan's probably better qualified to answer this, but I'll have a go at it. Sadly, there's probably a few more environment groups there than we'd hoped for, so if there was a smaller number, it would be quite easy to give, and we don't know how we're going to do it in the sowing guides. I think on the website and on apps, it's going to be quite easy to display that information, but certainly to put things on paper for Agzone 2, where there's 9 environment groups, plus a few extras that I left off the end that were like one-off sites. I really don't know. It's certainly something we need feedback on. The other issue about the interpretation of them too is we're not trying to predict what will happen into the future. As I might have said earlier, we're trying to summarise past performance on the environments that we've been given. So the inference, I guess, or the prediction we're making is for that environment group, but there needs to be some expert knowledge coming in to quantify what they might mean. Now, I'm not convinced that environmental covariates and all the things you might measure with soil type and rainfall and temperature and moisture and things, typically those sorts of models or covariates only capture about 30% of the information in those groups anyway, which is why we've gone the data-driven variety information. I was am I too naive to think that with some of the expert knowledge, when you see a group of 2010 sites or some of those individual trials separating out for 2011 or 2012, does that mean anything to you, or does it just beg more questions than answers?
We've got time for one more brief question and answer.
Reg Lance at Intergrain. You've just about answered the question that I was going to ask, and so the question relates to the predictability of the data. So the question really is, what are the additional bits of information that will be required to have an idea of what the predicted performance of a variety would be on a certain farm or in a certain region in a particular year? What's the missing bits of information, and or what's the information that we may have now that we could use?
Well, some of the determinants of environment groups will be known, I guess, and some won't be. And I guess that's why I like the share or investment portfolio strategy. You know there will be some seasonal influences. There are some things you measure that will affect future performance. But there's also the insider traders, or the things at the NVT sites, like the nematodes or whatever soil tests that you may or may not be able to make. It's $1 million question, and it's very good, but I'm not sure that we can actually measure everything that's going to describe the G by E. Steve Jeffries is sitting up there probably laughing at my reg. So, you know, can you actually quantify all the things that cause that G by E? I don't think so.
Sounds like it's a topic that's worthy of further question and discussion. I'd just like to bring it to a close now. Thank you very much, Alison. You